Welcome to Securing Digitalization, the Siemens Cybersecurity podcast. Our hosts, Natalia Oropesa and Mirko Ross.
Welcome to Securing Digitalizations, and today we will talk about cybersecurity in trains. And I welcome my fantastic co-host of the show, Natalia Oropesa.
And I welcome you, fantastic Mirko Ross. Happy to be here with you again.
Yeah.
And I am also very happy to introduce our special guest for today's podcast. And this is Krishna Pandit. He's the product and solutions expert. He's especially for cybersecurity at Siemens Mobility. So, Krishna, happy to have you. Thanks for joining us in this podcast.
Hi, I'm Krishna Pandit. I'm very happy to be here. Thank you for the introduction.
Krishna, if we talk about cybersecurity in trains, I always need to think about Hollywood movies, where a train is hijacked by evil cyber attackers, and then you need a superhero who saves all the passengers. How realistic is this scenario? Can, for example, a high-speed train captured and hijacked by a cyber attacker?
Well, hijacking is not the main use case for cybersecurity on trains because the train is going on a track and there's not much incentive to hijack. But otherwise, cybersecurity is very relevant for trains because if you look at other critical infrastructure like power stations, there you always have a fence around it. You have access control, you have security personnel making sure that no unintended people enter the site. Whereas in the train, the attacker is right there. So he can disguise as a passenger and he's right there at the system. And that's what makes cybersecurity in trains a very unique situation.
What we also see is that from a convenience reason, we are getting more and more connectivity for passengers in trains. For example, wireless LAN or entertainment systems. So is it as well possible to hack a train from accessing the wireless access point or the entertainment system?
Well, that is another thing that is very unique about the cybersecurity in trains, that you have pretty much all aspects of cybersecurity present on a train. We have the train control network, which has safety critical functionality. That means that is the part which is responsible for that if the train driver presses the button, that the brake is actually applied. We also have an operator system. Think about the information displays, which shows us next stop Munich, for example. And we have what you just mentioned, the passenger entertainment system, like a wireless LAN for surfing on the internet, or maybe a media repository with movies. And all of these are some sort of interconnected. And then we also have connections to the land side. For example, to send the diagnostic data from the train, but also to pull real-time information, right? Like when I say the next stop is Munich on the display and the connecting trains are delayed, that is real-time information which has to be pulled from the land side. And we also maybe have a ticketing system on the train where the credit card information is going through. So yes, so we have all these systems and they're all connected. And then the question is, can an attacker from the wireless LAN access it?
Let me, before you continue there, let me just summarize what you said and what I understood, which is very interesting because at the end of the day, in the train, what you have is a system of systems. Now you describe the train control network, you describe the operator network, and you describe the passenger entertainment network. And of course, you have to protect them differently. And you also need to isolate them so that you can avoid the hackers going from using the vulnerabilities of one of the systems, going from one system to another. I can imagine that you need to do that. And can you maybe leverage on the different protections that you need in the different kind of systems that you just mentioned?
Yes, that's a very good point. So, and for this, the network is segmented, and we into so-called security zones. We have like the train control network, which has the safety critical functionality, which is the most protected zone. And then there is a firewall. We call that the security gateway, which makes sure that it is shielded off from the other networks. So then, and the next level of security is in the operator network, which is again not as protected as the train control network, but still, has a good protection. That train operator network is also what's connected to the LAN side. So there again, we have a firewall, we have a VPN, that means like encryption. So to pull up the bar for attackers from the LAN side actually getting access to the train. And then, of course, but one thing also has to be clear, that the passenger network, the wireless LAN, there it is, that is the most difficult to protect, because there the attacker can gain access to. He has a lot of time. He might be bored when he's sitting on the train from, Berlin to Munich. He has many hours to do it. So that's why it is important to shield the passenger entertainment network from the other networks.
Yeah, and let me give you. Let me tell you a story that happens to me the other day, and this is related to this passenger entertainment network that is also showing information about the trip to the different passengers. I was sitting in a train in direction to Munich, and we were close to Munich, and then I seen the display, next station is Munich, which was correct. Now the difference is that the display was showing 10 o'clock as the time, which was the right thing. It was 10 o'clock. And then it says next station Munich at 9:30 a.m. So I was thinking like either the passenger entertainment network was hacked, number one. Possibility number one. Possibility number two, someone entered the wrong time. Or possibility number three, maybe they discovered the way to travel in time. And yeah, I was wondering if the train operator was discovering already the time machine. So I was very intrigued by that. But going back to the topic, because we are talking about hacking, and we can read in the news that actually the protection measures that we apply into the trains, like the ones that you just mentioned. But in addition to that, also the management of the vulnerability with, for instance, our Siemens product CERT, so the Computer Emergency Response Team. At Siemens, who are continuously monitoring and testing vulnerabilities in all Siemens mobility products and components. And this is one of the many measures that are helping us to protect the trains. And actually, you cannot read, fortunately, about trains being hacked. And the other reason because the trains are not hacked is because, of course, if you as a criminal have the intention to damage a train, of course, you will not necessarily go into the difficulty of hacking a train, but you would rather going to drive a truck full of explosives into the rails, right? This is actually what's happening in the trains.
If you think about sabotage, yes. If we think about ransomware and other stuff where you can get revenues out of a cyber attack, I think it's more a possible attack scenario, because as an attacker, then you can say, well, if I can do a ransomware attack or an outage of a train network, of course, this is the perfect ransom. But I would like to know as well, because we are talking about risks, as well about the risk assessment. So to me, a train, like take a high-speed train, is a super complex product, a super expensive, super complex product with a lot of suppliers in there supplying components as sensors, controllers, computers. How can you take care that the oldest components are still secure?
As Natalia mentioned, we have in Siemens, we have the CERT, where we have an infrastructure for vulnerability monitoring, and we use it very extensively. So, but as Mirko, as you said, we have more than 100 pieces of software on the train, right? And everything, and then you mentioned the sensors, we get them from a supplier, and then we have to make sure that every single piece of software is given in the vulnerability management. And then what do we do if we actually find a vulnerability, and just because it's, say, there is a control unit of the coffee machine has a vulnerability, do I have to then patch it and like take the train out of service? Maybe not. And for that, we do risk assessments.
And let me jump here. I think it's the best way to go, this risk-based approach. So by first defining what is the potential attack that we could suffer in a train. Second, by reviewing what kind of exposure do we have from the many vulnerabilities and weaknesses. And third, to explore if in fact someone has access, and how easily can someone use this kind of vulnerabilities. And by doing this, of course, we are assessing the risk. And once we assess the risk, then we know what kind of protection measure do we need to apply.
We had a strong focus on the train itself. I think it's also important to understand that this train is only part of an ecosystem or part of a customer journey. In real words, a customer journey. So I think one big topic is this intermodality. So where all those mobility systems are getting tied together to make a real customer journey from, let's say, using a car sharing up to a train, go to the plane and stuff like that. So it seems to me that mobility is getting super interconnected. And I had an interview with Christian Paulsen. He is the CCSO at Siemens Mobility. And I have asked him about the challenges in mobility regarding cybersecurity and privacy.
Yeah, most people, when they think of railways, they think of trains, but trains are one part of the complete journey chain for a passenger. And there are also stations, there's the whole infrastructure of the railway, but there are other modes of transport as well. And for a passenger, it's important to feel safe and secure when he uses these modes of transport. And it's not only the physical security they care for, but also the protection of their data, their private data, and the way they use, for instance, a transport system. So digitalization takes place in all of these modes of transport. We see that efficiency gains are seen, and they need to come together with the cybersecurity concerns that arise from digitalization. So mobility has to cater for these questions and challenges together and for our operators.
If we talk about cybersecurity in trains, it's not only the train itself. The train is part of a railway track, part of a signaling system, and part of a critical infrastructure. So there is not only the life cycle of the train you need to take in consideration, you need to take in consideration the whole infrastructure and the infrastructure life cycle. So how do we manage that?
Yes, so we use a risk-based approach. That is pretty much the only chance that we have. And this is actually where a train, which we already use the term system of systems, is different from a product. I mean, we use the differentiation between products and solution. A train is a solution. In a product, it's rather simple. I have a product like, say, a router or a or a phone, and then I can like do pretty standardized security measures on it. Whereas for the solution, I mean, I need a risk-based approach. So what we do is we take the entire train and break it into security zones, and then do a threat and risk analysis on these zones and try to assess what potential threats are there, what is the impact, and then find the adequate security measures.
You've told me that a train lifetime is 30 years, and it's clear that within 30 years, there may be modules inside a train which can't be secured anymore because you have no possibilities to update them anymore. Is it part of the engineering and the engineering design to build a train in such modules that you can run into a maintenance and lifecycle system? So can you say, well, I put out a completely component and this will be substituted with a new design?
So this is something that the whole railway industry is struggling with. So yes, so we have to get to the modules, and going forward, we have to make sure that only products and components are used which offer the support for this kind of lifetime, or which are connected in a way that hack of them would not have any impact, like further impact. I mean, I'll use the example of the coffee machine again. I mean, if I kind of say that I don't want to update the software of the coffee machine every few months or every year, then I have to make sure that it is connected in a way that by hacking the coffee machine, I can't do any. I might be able to disable it, but that, as you mentioned before, you can also disable the coffee machine like physically. You don't need a hack on it. But then that it's not connected, that I cannot disable it remotely, and that is also not connected to the rest of the train.
And that point, it's important that you can't use the coffee machine for a stepstone attack to level up in the system.
Let me here make sure that I understood that correctly. You say that the problem of the life cycle, because the trains, they are there for the next 30 years. This is a problem, number one, that everyone is concerned about. And number two, the way we address this is by dividing the systems into modules so that you can make sure that if you cannot update or replace one of the modules because they are too old for them to get a new software patch, let's say like this, that module doesn't expose the rest of the systems. Did I understood that right, Krishna?
Yes. We designed the train in a way that the different zones, as we call them, are separated from each other with very defined interfaces. And then what we also do is we periodically review the threat landscape and the situation. And if we then figure out that there is a certain risk in a component, we can see, is that a risk which we have to do something about, or is that a risk that we accept? And then we come to a conclusion. And for that, we also use the security vulnerability monitoring system from CERT.
Okay, so the answer of the industry must be modules, because otherwise I think you can't manage that for a long lifetime. And then that we need to think about how you can separate modules, how you can separate the APIs in between. And in the risk management, then to decide during the lifetime what kind of modules need to be stronger separated or controlled or monitored, or which are need to be exchanged.
I wanted to jump into another complication, and this is a complication of the standards and regulations for cybersecurity.
Yeah, that's very good. So,
and then, first of all, we all know that we don't have an harmonized landscape of cybersecurity regulation standards and norms. I would say in the EU, in the European Union, we kind of have this hope of the NIST, or the Network and Information Security Directive, since a couple of years already. And the reason I say this is a hope is because this is still not working perfectly. So now the question to you, Krishna, is how do you manage the compliance to these several different regulations and standards worldwide? First question. And second question is, do you have any difficulties in the European Union? Do you have their difficulties because one train is moving from Germany to Italy and now in Germany has to be compliant to some certain regulations and then moving down to Italy to another set of regulations? Is there something like this?
I'll take the questions one after the other.
Yeah.
So the first thing is currently we have a lot of activity in the legal landscape and regulatory landscape, right? You mentioned the EU NIS directive. We have national laws like the IT-Sicherheitsgesetz in Germany or Chinese cybersecurity law. And there is also a lot going on in standards, but there is no published standard for railway cybersecurity. There is one which is just in the making, the so-called Technical Specification 5701, which is being standardized in the Senelec. I was also part of the group there as a delegate. And what we also have is we have the standard IEC 62443. That is a widely accepted standard for industrial cybersecurity, but it is not specifically for trains. So the goal of the TS 5701 is to adapt the 62443 for railway. Now, what we are faced with is that we have all the customers and the government agency coming at us and saying, show us your compliance. And what we did, and I believe it's very innovative, we sat together with certification agencies and we found out that the best available standard is the IEC 62443, and they're the part 2-4. I mean, it has many parts, and this is the part relevant for us. And then we actually got a certification for that. And that was a very hard task because we have over 200 requirements and we have over 100 assets. And then you can see it's a combinatorial explosion there to map each asset to each requirement. But we actually succeeded in doing that. And that is, to my knowledge, the biggest industrial cybersecurity certification ever worldwide, not only for trains, but also in the entire industry. And this is something now that customers accept because they see that we do solid work there, and we also got it now externally certified.
Krishna, wasn't the railway industry always facing the questions of standardization? Let's think about the railway tracks when you were moving the size from the railway tracks when you're moving from one country to another. So there was always the challenge to discuss about what are the right size of railway tracks. So I think in cybersecurity now it's the same. If you are moving from one country to another country, you need to have a common understanding. What is the common size of cybersecurity and compliance standards?
Yes. First of all, what you're saying is right. It is the railway always has to do with standardization. If we look at the safety scene, which is somewhat similar in a process view, there it took decades to find standardized, appropriate ways to ensure safety compliance. With cybersecurity, we are just at the beginning. We are just seeing that the laws and regulation is being published. And with regard to moving to other countries, also going back to what Natalia said previously, it is a challenge. If you look at the history of Europe, countries, if taking like Germany and France, fought wars with each other for 150 years, right? And there the goal was always to make the railway systems as incompatible as possible so that if one country invades the other one, that they can at least not use the railway system, right?
No way.
And now, luckily, we have the peaceful situation for the last 70 years, but still we still have to combat 150 years of trying to be as different as possible and now bring it all together. And that is for the entire railway industry a big challenge, not only for cybersecurity, but we are doing our best to make that happen.
Wow. Because I learned so much in this podcast that I would like to summarize what I learned. Trains are a set of different systems. So we talk about the train control system, the operating system, the passenger entertainment system. We also talk about the challenge that we have in the trains or with the trains from the life cycle perspective, because the trains are done or construct for 30 years at least, if not more. So we have a challenge there. Third, learning, there are no specific regulations for the protection of trains. And we also have different regulations to follow around the world. And we even have a challenge in Europe with many different specifications/regulations that the countries are requesting. So this is the complexity of trains, I would say, in a nutshell. Now, what I also learned is how to address these challenges from a cybersecurity perspective. So number one, I hear segmentation, making sure we have proper protection for the different systems that we have, for the train control system, for the operating system, for the passenger entertainment system. Second, we want to have a modular architecture so that we can deal with the challenge of the life cycle, making sure we understand the risks that each module has and then apply proper measures, whether this is a software update or maybe the renewal of some of the modules. It depends on the risk of the modules that of the risk that they have. Number three, working and influencing the development of new regulations more specific for the trains so that we can address as well the standards and regulations needed in the train industry. And also very important to make the detection of the vulnerabilities in a continuous way and address those vulnerabilities with bigger risk. This is what I learned today a lot. Am I right?
You're right. And let me add, we can't win the battle to secure the train systems as a single nation state, as well not only as European Union. So this is as well a challenge towards cultural and cooperation, being open to fit the things together. And this is as well a great challenge. So by that, I have to learn as well a lot, Krishna.
Krishna, thanks a lot. It was a real pleasure having you here today. Thanks for giving us that many learnings today. Thank you.
Thank you very much. It was great to be here.
And if you like the podcast, give us a rating, follow us, and as well drop a comment. And thank you very much.
Securing Digitalization, the Siemens Cybersecurity Podcast.